Here are a couple more antiderivatives that look very similar to one another. Notice that the only difference between these two is that there is a 4 in the numerator of the first one and a 4x in the numerator of the second one. So we're going to find a very similar sort of comparison between these two and the last two, right? One of them is going to be an inverse trig problem, the other one's not. So let's take a look. Let's talk about that first one. That should look familiar to you. It should look kind of like the arctan, right? We've got a constant on the top, and we've got constant squared plus variable squared, right? Let's go back up here and take a look. We've got a constant on the top. Keep going. Oh, man. There we go. We've got a constant on the top, along with the du or the dx, and then we have a constant squared plus variable squared on the bottom. Okay. One thing we want to make sure we remember is that 1 over a with the arctan, right? That shows up with the arctan and it shows up with the arcsecant. In our arcsine example, we didn't have to worry about it. The 1 over a does not show up in that one, but it does show up in the other ones. So be careful with that. That's an easy thing to forget. All right, so similar process. We want to figure out what does a equal, what does u equal. So we're going to let u equal whatever the variable that we're squaring is. In this case, we're squaring the variable 3x. And we're going to let a equal whatever the constant is that we're squaring down there in the bottom. Of course, we're squaring 5 to get the 25. Now, we don't have to worry about anything with a prime here, but we definitely have to do u prime or du dx, right? We want to get rid of the dx and replace it with the du, and we're allowed to do that, provided we figure out what dx equals in terms of du. And it equals du over 3. So we're going to go ahead and rewrite this. We're going to put the 4 is just a constant. We'll just leave that there. 25 is the same thing as a squared, right? A is 5, so a squared is 25. And 9x squared is the same thing as u squared, because when you square 3x, you get u squared, or 9x squared. Dx is the same thing as du over 3. All right, so that means that we can factor out a 4 in the numerator and a 3 in the denominator, and what's left? We've got a du in the numerator, and we've got an a squared plus u squared in the denominator. Lo and behold, this part right here, not the 4/3, but the rest of it, is exactly what our formulas tell us about, right? The integral of this equals 1 over a times the arctan of u over a plus c. So we're done, except we have to remember to replace the a with 5, and we have to remember to replace the u with 3x. And instead of rewriting that whole thing, how about I just say 4/3 times 1/5 is 4/15. And that would be it. Okay? So don't forget that 1 over a. Again, that shows up in the arctan and the arcsecant equations, but not in the arcsine equations. And then I think you already know what's going on in this next problem because it's so similar to the last pair that we did. Remember that x up top means, okay, well, this is linear compared to quadratic. So if we just let u equal the entire denominator, then this is just a basic u substitution problem. There's no arcsines or arctans. There's no inverse trig involved here, right? It's just your generic u substitution problem. So we'll go ahead and figure out that du over 18x equals dx. So when we do our substitution, we get, we'll leave the 4x for now. We've got, instead of 25 plus 9x squared, we have u. Instead of dx, we have du over 18x. So we can factor out the, well, before we do anything, let's note the joyous canceling of the x's. We needed that to happen. 4 over 18 gets pulled out. And we've got the integral of 1 over u du. And if we haven't seen that many times recently, then I'm not sure we're paying attention in class, because this is something we've seen a bunch recently. So this is 2 over 9. This is what 4/18 reduces to. And of course, this is the natural log of the absolute value of u, or 2/9 natural log of the absolute value of whatever u equals, 25 plus 9x squared. 25 plus 9x squared. Do we need the absolute value bars? No, 25 plus 9x squared is always positive no matter what x equals, but it's not a bad idea to just leave it in there anyway. And again, take a look at that subtle difference of the x in the numerator in the original problem, right? Just the fact that we've got an x here where we don't up here completely changes the look of the entire problem and changes the method that we use and everything. So definitely something to keep track of as you're working through these problems.